Oh, perfect. You're just in time. I was just about to teach how to write perfect code. Oh, come on, Jamie. You can't write perfect code, can you? Of course you can. You can do that by using test-driven development. And today, I'm going to show you how to do exactly that. So if you want to learn to write bug-free code, just like I do, let's dive in and learn how to do TDD. Test-driven development flips the script on regular development. Instead of just writing your code, you instead first write a failing test. You say, or let me rephrase it a little bit. You write a test that expects this as the output, and then you write the code to make that test pass. So you write the test first, aka test-driven, and then you write the code, development. When I first started writing TDD, it felt a little bit slower where I wasn't immediately jumping in and starting to write code. I don't know about you, but when I was a kid and I looked at a maze, I tried to, start at the beginning, work my way through, and then I would get stuck at dead ends, have to work my way backwards and try again. That's how I feel about code, where you start down a path for a solution, it's looking good, and then you're like, no, that doesn't work properly because this didn't work properly. With test-driven development, it's kind of like a maze, but instead of starting at the beginning, you're starting at the end and you're working your way back. I don't know about you, I always felt it easier to work my way backwards in a maze to get to the start. Some might call that cheating, but hey, I think it's just smart. Okay, so we've got a little bit of an idea of, I guess, the theory behind test-driven development. And so now let's go and look at a practical example. In today's example, I'm going to do something called FizzBuzz. And so with FizzBuzz, we're going to make a function that's going to do the following things. If a number is divisible by 3, we're going to return the word fizz. If a number is divisible by 5, we're going to return the word buzz. If the number is divisible by 3 and 5, we're going to return FizzBuzz. Otherwise, we're just going to return back the number itself. Sounds good? All right, cool. But instead of just writing the code, we're going to instead start by writing a failing test first. So in my case, I'm going to use Visual Studio and C#, but the principles are the same. It doesn't matter what language you're writing this in. It could be PHP or Java. The principles are the exact same. It's really just syntax at that point. So I have Visual Studio 2022. This is the community edition, which is free. And on the right over here, I have this really cool tool called NCrunch. There'll be a link in the description. NCrunch is just perfect for demonstrating test-driven development because every time I write code, it's going to automatically compile it and run any tests for me. So you'll see this in action here in a second. So to start, we need to write our first test method. So let's do that. And we'll start with something very simple, and that's going to be given 1, expect 1. Seems like a pretty straightforward test, right? We said whatever number is passed in that's not divisible by 3 and not divisible by 5, we're going to return back the number itself. So with our test, we're going to start with what we expect the output to be. So var expected equals 1. Now we're going to do var actual equals FizzBuzz, which is going to be what our function that we're going to build is called, and we're going to pass in 1. And then we're going to, oh, look at this amazing stuff from Visual Studio, auto-completing exactly what I want. We're going to assert that our expected value of 1 is the actual value of the function FizzBuzz. So, as you can see, our code doesn't even compile because there is no function named FizzBuzz. So let's create that now. I'm going to leverage the Visual Studio shortcut Alt-Enter, and it's going to preview generating the function for me, which looks great. I will change this variable from v to be called input, so it's a little bit more readable. All right, now you can see it. Over here, we have our failing test. Perfect. This is exactly what we want. This is how test-driven development works. We have a failing test. Our goal is to make that test green. So how do we make that test green? There's a few school of thoughts here. One of them is like really strict where it's like you have to write the fastest code possible to make that test green. How would you do that? Well, you would return 1 because that's what we expect. Now, I'm a little bit more pragmatic, and if I see a solution that's a little bit, not completely hard-coded, I'm going to do that right now. So that solution is, I'm just going to return back what was passed into me. Return back input. Cool. That works. Now, again, like I said, I could have done return 1, and as you can see over here, the test also passed. But, that's not as good. So let's go back and we'll just return back input. Perfect. Now, before we move on, we can maybe write a few other test case scenarios where we want to make sure the last case is still working properly, which is any other number. So actually, let's copy and paste this method. Why type something that's going to save me a little bit of time? And let's change this test to be given 0, expect 0. So again, we'll change our expected value to be 0, and we're going to pass in 0. And as expected, that test goes green because it already works properly. All right, cool. So we've got our given any other number, return back that number. Next up, we need to write another failing test. And so to do that, we said any number divisible by 3 needs to return the word fizz. So we'll go given 3, expect fizz. All right, and once again, so this time our expected is going to be fizz and not a number. And then again, we're going to go var actual equals FizzBuzz. We're going to pass in 3. And once again, we're going to assert the expected is the actual value. And as we can see here, our test failed. Perfect. Once again, we're doing really well with our test-driven development, where we get in a failing test and then we need to make that test pass. So once again, there's a few school of thoughts here where you can write the simplest code to get the test passing and then carry on. So once again, if we were to do that, and it's not my favorite example, but once again, if input were to equal 3, we can return fizz. Now, as you see, our function doesn't compile again because the auto-generated function returned back an integer, as that's what we were expecting originally, whereas now we can have a mix of integers and strings, so we're going to change that to be an object. Once again, perfect. The test passes. Again, I don't really love the hard-coded value, and I'll kind of show you where there's a few different school of thoughts and whether you got to go follow by the book or whether you can, look at the better solution and just kind of do it. So we're immediately going to copy this function and we're going to, again, write the failing test because that's our goal. So given 6, we also expect fizz. And we change our input here to 6. And once again, the test fails. So, we could continue on this hard-coded path of if input equals 6, return back fizz. But at this point, we have an opportunity that we have some existing tests, and so we can refactor our code to make them pass. When we go and refactor our code, our previous tests will help show that we didn't break anything, which is exactly what we want. That's the purpose of test-driven development, to write perfect code. It allows you to refactor it and make sure that you didn't break anything, because all of your existing tests will help show you that everything is still functioning exactly as you expected. So, as we said, if the input is divisible by 3, we return back fizz. And once again, we have our code working properly. However, look at this. This is perfect. Given 0, expect 0. We broke this test. Why? Because 0 is apparently divisible by 3. Kind of a little weird one. But that's exactly what we want. We know that we just wrote new code and it actually broke our existing code. So that's perfect. So in this case, we can go, what's the fastest thing? We can go if input is, let's go less than or equal to 0. We can also return back input. Kind of don't love the duplication here where we're returning back input, but let's carry on for now. It's okay. It's not the worst thing in the world. So the next thing we need to solve is when it's divisible by 5, we want to return back buzz. So once again, let's copy our test, and we're going to go, in this case, given 5, we expect buzz. So we're going to change our expected output to buzz. We're going to change our expected input to be 5. And once again, we have a failing test. We expected buzz, but we actually got back 5. So how do we implement that? Basically, it's the same thing as this. Instead of divisible by 3, it's got to be divisible by 5. So once again, let's copy and paste this code, change it to be divisible by 5, and return back buzz. Perfect. All of our tests are green again. This is looking great. Now, kind of like we did earlier with the 3 and 6, let's write a different test case as well, just to make sure that our code works for not just the number 5. So in this case, we'll go given 10, we'll still expect buzz, and we'll pass in 10 instead of 5. All right, that's looking good as well. All of our tests still pass. Now, the final thing we need to do is handle the last test case scenario, which is when it's divisible by 3 and 5, we want to return back FizzBuzz. So in that case, the first number that comes to mind would be 15. So let's go ahead and write our code. Given 15, we expect FizzBuzz. So our expected, I don't know why I didn't copy and paste this. I'm spending so much time writing extra code. Ugh. Our actual FizzBuzz equals 15, and then we want to assert that it's equal. And once again, we have our failing test. Perfect. We need to write the solution for it. Now, once again, I want to show another example of writing code that doesn't work properly and breaks things, or just doesn't make the test go green. So we know our solution is very similar to these things where it's divisible by 3 and 5, but this case we need to do them together. So once again, I'm going to do a slightly different example that's not going to work properly, but that's okay because it's just I want to show what happens here. So if our input is divisible by 3 and our input is divisible by 5, we want to return FizzBuzz. And as you can see, what we expect, it didn't work. It got back fizz instead of FizzBuzz. So this is a really cool aspect of NCrunch, and why I love it is you can actually see a couple different things here. One, it's showing you where this test failed because there's a red dot on this line, return back fizz. So we know that this line of code is specifically causing our test to fail. That's really cool. Now, as we said, we know what the actual answer is, and that should be this one. If it's divisible by 3 and 5, we should return back FizzBuzz. Once again, you can see there's a little white dot here, which means that this code, as you can see by the hover, is not covered by any tests. So we know that this code is not doing anything, or at least it's not tested, which is really neat. So once again, we know what our solution is. We need to move this first. And so we're going to cut and paste that, and now all of our tests go green. Cool, that's perfect. And once again, NCrunch is really cool that if we look closely, every single line of code in here is covered by a green dot, which means everything is properly tested. Hence, we've written perfect code, exactly what we wanted, exactly the goal of this. And that is why we do test-driven development. Once again, when I first started with this, I thought there was a lot of overhead as well, writing unit tests first and then going and implementing the code, when I already knew the solution. Oh, it's very simple. If it's divisible by 3, return back, fizz. I could have written all of this without writing a single test, and that's good. Now, other people, when we want to write code as well, we do want our code tested. So, there's other people who will write the code first and then go back and write the test afterwards. And there's some flaws with that. And the flaw to that one is that if you write the test afterwards, you might not actually write what your expectation is supposed to be, but instead you'll write the expectation that was actually returned in this running of the function. And, you know, I've seen that many times. I've been guilty of that before, where I write an incorrect test that's expecting the wrong value. Test-driven development, you just can't do that because you write your expectation. So hopefully this example has showed you exactly how test-driven development writes perfect code every single time. And I hope you enjoyed this example and learned something out of it. Thanks a lot. Happy coding.